Hello C-Block, this is Bautista Diur, working with Jeronimo on April 24th, and I'm currently jumping on a trampoline. So, I'm gonna jump right onto the subject. For our project, we're gonna measure the period and frequency of my jumps. We have placed measuring tape to measure the amplitude of the first jump. The time it took for the first jump to go all the way down and then back up was 0.15 seconds, which means that the period for the first jump is 0.15 seconds. We also collected the amplitude, which is 0.08 meters, as you can see in the picture. To find the frequency of the jump, we divided 1 over 0.15, which calculated to 6.6 Hertz. So we're gonna jump right into the next jump. It's hard to see at first, but
Perfect pick.
we were able to catch the amplitude of the trampoline. The time it took for the second jump to go all the way down and then come back up was 0.14 seconds, which means that the period for the second jump is 0.14 seconds. We also collected the amplitude, which is 0.075 meters. We did the same as the first jump and divided 1 over 0.14, which got us a frequency of 7.14 Hertz. In all three jumps, the amplitude isn't necessary to find the period, but it makes it easier to measure the time it takes for the trampoline to go all the way down and up to its original position, which for the last jump was 0.09 seconds. The period is the time that it takes a complete cycle or wave oscillation to occur. We divided 1 over 0.09 and the frequency equaled 11.1 Hertz. A frequency is the number of cycles or vibrations per unit of time, also the number of waves produced per unit of time. When we finished collecting data for each jump, we found the average period by adding up the 3 jumps and dividing it by 3. We got a period of 0.126 seconds. We did the same thing with the frequency and got 8.28 Hertz. We captured the time with the application Perfect Pick. Each definition was found in the physics textbook. All team members contributed equally to the finished product.